Hello and welcome to another science video by Johnny. In this one-on-one lesson, I and Mr. An, we will explore space. Basically, this is a learning activity 3.4, exploring space, and we'll look at Canadian contributions to the space race. So of course, he's studying a Canadian program, North American program. So of course they will have something to talk about how Canada contributed to the space race during the Cold War. Can you read that?
Yeah. Canadian played important roles in the early days of the
So
space
it means in the
program.
later day they don't play any roles? I was like, what is it supposed to mean?
Many of the first scientists and engineers at NASA were Canadian. They were part of the team designing and building the early space capsule, the lunar landing module, and the complex computer navigation system. They were also part of the team that supervised many spaceflights and determined how best to orbit the moon. Canadian industry also built components for the Apollo series of spacecraft, such as the landing gear on Apollo 11. Canadian was the fourth nation to launch a satellite in 1962. Satellite Alouette-1 was launched.
Alouette. Alouette.
Alouette.
You know what
Alouette.
Alouette is? There's a
Not
song. There's
sure.
a song name of Alouette. Maybe you have heard when you were younger. Alouette. Da, 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 da. Ever heard of that?
Oh, I heard it before.
Of course, that is the name of
Hmm.
the song, and they named these satellites like Alouette 1.
They
Oh my
remain in
god!
orbit today.
Now
Although
YouTube,
still in.
bot is gonna recognize that tune, and it's gonna cause problem. No? Oh my god! YouTube's terrible now. Just the tune alone can basically make make YouTube like recognize it, and then they inform the copyright owner. It's terrible. Please continue. Canada was the fourth nation to launch a satellite. Can you continue, please?
Oh, yeah. A replica of Canada's first satellite, Alouette-1, launched in 1962. Another significant Canadian contribution was the spacesuit, which
G
was
suit.
based on the Canadian invention, the G-suit. During World War II, fighter pilots used the pressurized
G suit to prevent them
G-suit
from passing out.
during high-speed maneuvers.
Maneuvers like you have to dogfight on the. You have to basically be dogfighting on the sky. So in the sky is where you have to dogfighting a lot, and it's very stressful. Some people they just they stress they pass out. So that's why you have
Yeah,
to use spacesuit to prevent things from happening like that. G suit. Everyone was like, "Oh, this is my invention, not your country invention." I don't know why, but it always sounds like that now. It's like it's all about national pride. All right, can you continue?
Neil Armstrong wearing an early spacesuit based on the G-suit invention. Canadian during World War II. Benefit of space technology.
Mm-hmm.
Landing on the moon and returning safely back to Earth required the development of new technologies and material. Many of these developments led to the creation of important products and technology that we now rely on.
Because basically we are going on to go to space and going to a planet that is we haven't been before there. We have never been there before, so the conditions are different now. So it means you need new technology and new material to adapt to that new condition. And because of this
Yeah.
development, in space during a space race. It led to the creation of many new important products now that we are still using. We're still relying on them. Okay, there's some example.
Following table lists some example material were designed for the space program and converted into product use every day. Polarized lens and visor to protect during the spacewalk when on the moon.
Because
Used today.
basically over there, there's a lot of like sunlight, and you know, dangerous rays to the eye. So that's why we have to have polarized lens in lenses in sunglasses and cameras to reduce glares. So it makes the image more clear and less glares. And also it protects the eye too. I have something like that. I just put onto my eyeglasses and then I can go out. And then looking so cool, like I'm wearing a sunglasses, you know.
Yeah. Fire retardant material to prevent fire in spacecraft used today. Protective suit for firefighter and used to fireproof children wear. Communication satellite to communicate with distant spacecraft used today. Enable
Cell phone
cell
and GPS
phone.
units and TV.
Quartz watch crystal.
Quartz watch crystal. So basically quartz is a special material. Quartz glass is actually quite expensive. But quartz watch crystals and high accurate onboard clocks. So basically to make like clocks on the spacecraft, basically just clocks, onboard clocks, and it's highly accurate. Coordinate the firing of rocket engines, watches, clocks, and computer. Quartz are still being used a lot these days. In the lab, you can see quartz glass pieces used in like very expensive machines.
Wow.
Like for example, mass spectroscopy (MS). This machine costs like I think up to 10 billion Vietnam dong. I think it can be
Whoa.
that expensive. These machines are extremely expensive because they are highly accurate, and they have to be made using like very special materials, and highly reputable companies will make them. Not everyone can make them, of course not.
That's a lot.
It's a lot of money.
Yeah.
Alright, let's move on. We have barcodes, like barcode, you know, used to keep track of
Yeah.
all the millions of parts in the construction of spacecraft. Because there's so many small little parts, you have to keep track of them using barcodes. Otherwise, if they gone missing, oops, something went wrong.
Yeah.
And sometimes spacecraft wouldn't work because one or few parts were missing, you know.
Yeah.
Checkout counter, inventory, checkout counter, beep, beep, beep. Yeah. Microcomputer technology. Using notebook and tablet, computer and cell phone. Tablets. So basically, tablet these days, we have microcomputers, like extremely small computer technology, just to make these things extremely lightweight, so you can bring it to space. You know why we have to make things lightweight?
Uh.
Why we have to bring very lightweight things? to the outer space?
Because
Why do
because I
aircraft
think
has to weight all of the components like customers, got like luggage? They have to weight everything before the airplane take off. You know why? Because the heavier something is, the more fuel you need to bring it up to the atmosphere.
oh
So that's why the less weight, the better. So you will spend less fuel, and less fuel means less money being used.
oh
So basically, that's why aircraft they have to weight a lot of things too, like human, of course, and then they have to weight a lot of pieces of luggage that people bring up there. So if you exceed a certain amount of kilograms, you have to pay because of that.
that's why. Oh, I get it.
You get it now, huh? Because
Yeah,
the heavier you bring up there, of course, the more money they have to spend on fuel. It burns more. It has to burn more to basically push the spacecraft up. It's not
yeah,
because they are greedy. It's because they have to be economic. Because they are running a business after all. They spend more money on fuel. You have to pay more for that fuel.
yo.
That's why. So that's why I
That's so dumb.
say the lighter the better now.
Microcomputer technology
Mm-hmm.
allows spacecraft to carry lightweight and small computer and come in space. Yeah,
Using notebook and tablet computer and cell phones. So these days, tablets and phone can be as strong as the laptop of yesterday. Of course, they
yeah,
cannot perform as many functions as a laptop, but they are small. Of course, they are way more smaller. I'm waiting for the technology. Like you can have helmets that has like vision, like a slit that has all the numbers and all the things that you can see on like sci-fi movies. You can listen to music. You can see like all the information, just like a computer. But those things wouldn't sell. Not many people would buy them. That's why they don't make them. Not because we cannot do it, but because not many people will buy it. So making it would be not so cost effective.
what is the current use for the lightweight composite material invented to make spacecraft as light as possible?
All right, so you answer this one now. I'll take a little bit break.
The
You
program
say
was
something?
called
Okay, so
and
exploring space. Basically, we talk about satellite, like
yeah,
Salyut 1, Salyut 1, Salyut. I think Salyut 1. The first space station was launched in 1971 by the Soviet Union. Three-person crew lived on it for 3 days, but they died in an accident while returning home to Earth. Oh my god. You know, the Soviet Union was not always about safety, you know.
Yeah.
Oh my god. Alton station was abandoned. The station crashed back to Earth after 6 months in orbit. I mean, they were not the most safe people, to be honest. They didn't think about
Oh.
crew safety that much, I think.
Oh man.
Right. Salute one. Solar panels. So, basically, these solar panels help the space station to, get energy from the sun, so they don't have to depend on fuel anyway. But of course, up to the point it needs energy somehow. So maybe the solar panels will not be able to provide everything it needs. But the fact
Yeah.
that the fact that the station crashed back to Earth after 6 months in orbit is just like, I don't think it's of good quality. Maybe I'm wrong. Maybe.
Maybe Skylab.
Mhm.
Skylab was the first American space station. It was launched in 1973 and
Remain
remained in
orbit until
orbit into.
1979.
In addition to its living quarter, Skylab includes space-mounted telescopes to study the Sun and a large laboratory for conducting experiments. Skylab was powered by a solar panel and it also had a small booster rocket
Mhm.
to adjust its position in orbit. It could dock with a spacecraft, allowing crew and supply to be replaced at regular interval. The Meter astronaut crews stayed regularly on Skylab during 1970.
Mhm.
They lived and worked together for a month in a cramped space that was about the size of a
One bedroom
one.
apartment. It's very cramped, but they have to work and live together like that. Never mind. In the armies, or sometimes the same thing too.
Oh, yeah. Most of the experiments that took place on Skylab examined the effect of low gravity, microgravity on the astronaut. As well, thousands of photographs were taken of the Sun and Earth using a variety of cameras.
Mhm.
In 1979, Skylab reached the end of its life and was allowed to fall back into Earth's atmosphere. As it fell to Earth, most of it was burned up by friction with the atmosphere. Mir.
Mhm. Okay, so Mia, of course, another Russian invention. I mean, space station. Oh my god, the noise out there. People were doing something out there.
Is it in your place or my place?
My
Because
place.
audio.
People were just making a lot of noise out there.
Mir was a space station built and maintained by the USSR, later Russia, that was in orbit from 1986 to 2001. It was constructed in space from a module carried by rocket that docked with the station as you can see in this image. Mir was powered by many
Many solar what?
solar panel.
Okay.
Several Mir occupants spent more than a year in space. Experiment were carried out in medicine, biology, weather, astronomy, and physics. Mir was also used to develop technology necessary for long-term survival in space. Mir's fate was the same as that of Skylab when it reached the end of its mission in 2001. It was allowed to be pulled down to
Okay,
Earth.
anti-gravity mostly burn up while passing through the atmosphere. Basically, when you enter the atmosphere, things start to burn because of
Yeah,
oxygen and because of the velocity in which you move. So basically, you start to burn like a comet, you know.
okay. During the period when Mir was active, political tension between the Soviet Union and the US began to ease. By the 1990s, the Cold War has ended, and the USSR had split into several countries, including Russia.
Mm-hmm.
The US and Russia gradually began to cooperate on space exploration. Mir represented the instant of international cooperation in space. The station was visited by American spacecraft and hosted astronauts from 12 countries. The International Space Station.
ISS is still being used today, you know. ISS basically it's one of the biggest space station, and then we build it for internationally, so everyone can use it, not just any country, you know, not just
Yeah.
like a single country. It's like for everyone, so that's why it's called International Space Station. Incredibly expensive, which makes it hard for a single country to pay all the cost. US, Europe, Canada, Russia, and Japan. All of these countries just combine together and do this.
Cool.
Designed to create a permanent lab facility in space. As it's so large, many solar panels are needed to power it. Of course, the larger you are, the more energy you consume. So you need more solar panels to be able to absorb sunlight and to create electricity, you know.
Yeah.
So not always the bigger the better. No, it's not always like that.
Construction of the ISS began in 1998 and expected to remain operational until at least 2028. The ISS is much larger than Mir, and Mir and can be seen at night with the unaided eye. The orbit of the ISS is higher than so the result. It can stay, which mean there is less influence from Earth gravity.
Mhm. So basically, you're on a higher orbit than the other orbits. So, but other orbits, other satellites are on like low orbit. So of course, the lower it is, the nearer to Earth. So the more gravity will affect it. So this ISS is on like a higher orbit than the others. So there's less influence from Earth's gravity. So it's stay in orbit longer, you know.
Yeah. A wide range of experiments have begun carried out on the ISS, and most related to the effect of microgravity and the technology necessary for traveling to Mars. Astronauts from 15 different countries have served on board the ISS, including many Canadian space agencies, foreign
Of course,
organizations.
always about nationalism. A lot of, including a lot of us Canadian.
Still biased.
Very biased. Why this one has to be so biased with country name and things like that and contribution? Weird.
Yeah.
I wonder why. Why they have to do that?
Space Shuttle. Space Shuttle were designed by NASA to transport astronauts and equipment to orbiting space station. They could take off like a rocket but land like an airplane and could also be reused many times. Space Shuttle flew from 1981 to 2011. They carry many communication satellites to space probe as well as component for space station. such as Mir and the ISS. The ISS could not have been built without a space shuttle carrying a large component into orbit. The space shuttle could carry up to 8 crew members to replace the crew on the ISS, along with all the equipment and supply they would need to spend many months in space. In the early shuttle mission, the crew was made up entirely of trained astronauts, but later mission include civilian crew members, such as scientists, engineer, and teacher. 5 space shuttles were built. 2 were destroyed in action, and the remaining 3 have been retired and are on display in museum.
The Canadarm. Like, I was like, is it Canadian farm or is it Canadian arm? So it turned out it's a robotic arm to move cargo in space. To remove the joint corresponding to the shoulder, elbow, and wrist. Hmm.
A robotic arm was designed to be part of the space shuttle and was used to move cargo in space like a human arm. It has 3 movable joints corresponding to the shoulder, elbow, and wrist. Vanadium Arm 1 was controlled by astronauts inside the shuttle who used it to launch satellite and space telescope. The shuttle cargo space. It was also used to retrieve objects from space, returning them to the shuttle for repair in 2001. A new version of the Canadian Arm, called Canadian Arm 2, was attached to the ISS for use in constructing the space station and for giving astronauts a platform from which to work. Then, in 2008, a robotic handyman called
Extra.
Dexter was introduced that can be attached to the arm and perform work previously done by astronauts. Another bias. The contribution of Canadian astronaut. Well, since 1983, about a dozen of Canadian astronauts have been part of NASA space mission. In 1984, Mark Carney was the first Canadian to go into space.
Mark Ganu was the first Canadian to
Mark
go into
Carney,
space. Well, I know that Canadians are actually very nice people. A lot of them are very nice people. Chris Hatfield, the name of the
Chris
third name,
Hadfield.
yeah. Chris Hatfield basically is one of the most famous person. He's still alive right now,
I know.
being held into his spacesuit. Chris Hadfield basically sang a song and put it on video on YouTube, and then the video received like so many millions of views. Where he was singing the song from David Bowie. What's the name? Space Oddity. A 1969 song, Space Oddity. Very famous one.
Boda Ponte.
Roberta Bonda.
Education BS in zoology and architecture.
Agriculture.
Animals. Oh,
Master in
I,
pathology. So she learned about like disease and stuff. So basically she's a doctor. Kind of a doctor. Pathology and then microbiology. Oh my god, PhD in microbiology was like she's really good. Because microbiology is just really hard. It deals with the brain and the spinal cord and the central nervous system, very difficult stuff. MD in neurology, so she's a doctor. So she's an MD in neurology, I mean doctor. She's a medical doctor in neurology, so it means she's a neurologist, doctor.
oh,
So she's just really smart, just really, really highly achieved. That has a lot of achievement. Julie
yeah.
Payette and Julie Payette.
Julie Payet.
So she's only having a master in applied science, and that's it. She's a jet pilot.
Jet
How many
pilot.
years? I mean, it seems like she doesn't have that many achievements aside from master and bachelor degree. How about Chris Hadfield? I wonder. Graduate. He has even less. BSc in mechanical engineering, graduate research in. Oh, he's a graduate research in aviation. So maybe he has a PhD already. Maybe.
Yeah.
I'm not so sure. Graduate research. What does it mean? Because you can go from bachelor, you don't have to go through master, but you can just do research immediately, and then go into you can get your PhD without master. I mean, that's doable.
Future of space travel. Mars is a rocky planet. It is smaller than Earth, so its gravity is potentially less. It also has a very thin atmosphere, which means that there is no air to breathe and deadly solar radiation can reach the surface. The average daytime temperature on Mars is approximately minus 100 degrees Celsius. When the sun shines, it can warm up to 0 degrees Celsius.
Wow, so warm, 0 degrees Celsius. It's just really cold. It's a cold, bloody cold desert.
Yeah, but once like the sun, like move closer, it would like Mars
Yeah,
will
but not that
would
much. I mean, it's still cold. It can warm up to 0
yeah.
degrees Celsius. Zero is when like ice form, you know. Could be a super site for space station. Basically, we can change its planet. Like if we form CO2 in the atmosphere, it will capture the heat, and then it will keep the temperature of the planet like similar to Earth, you know. We can do it. I mean, we have been making a lot of CO2 with global warming and thing, you know.
Yeah.
So it's doable.
The US has sent several robotic rover craft to drive across the planet's surface and analyze samples of the rock, soil, and atmosphere. Each rover is powered by solar panel and equipped with drills, camera, and analysis equipment.
Analysis equipment to test the Martian soil.
The biggest challenge of sending people to Mars
You
is the
need three
time.
years right now with its current technology.
Oh,
Wait, they say journey to Mars will still take about a year. Huh? I thought it was like 3 years. At least another year to get back. So, you know, say 2.5 maybe, almost twice as long as anyone has spent so far. But then you need to do something on Mars too. So let's say 3 years. It's like you come there 1 year, and then you have to do something on Mars, and then you come back, which is at least another year. So about 3 years, say.
Mars, a journey to Mars will take about a year. It will also take at least another year to get back. This is a long time to be in space and almost twice as long anyone has spent so far. Can human go to Mars?
Hmm? You say what?
Oh, this. Human
Should
goes to
human go to
Mars.
Mars? Of course, we should. But right now, we need better technology. Like, we need way faster spacecraft, like maybe getting people to Mars in 1 month instead of in 1 year, you know? We need way faster spacecraft. We need new technology.
Sometimes scientists and engineers argue that the next logical step is to try to send astronauts to Mars. This will be much more expensive for government and sending robotic rover and will require far more planning and training. But it felt that human could do a lot more research than robot,
Hmm.
since humans are so much adaptable.
Of course, we are
Said
way more adaptable than robots.
yeah.
No spacecraft that has landed on Mars has returned to Earth. It's like there's something that eats them up or kill them or something.
Yeah.
No, I mean this sentence weird because it implies that we're not coming back. It's like, it's like that. Oh my god. This, I mean, this sentence funny. Even though there's no real danger, there's nothing like space alien trying to kill us or something. But this sentence so funny.
Sending human to Mars would not be easy for many reasons. So far, no spacecraft has landed on Mars has returned to Earth. There is also currently no rocket large enough to launch a human mission to Mars. It is also unknown that the effect many years of zero gravity would have on human health. Some of those in favor of sending people onto Mars suggest that spin-off technology from innovation will provide economic benefit. Others believe the mission would be inspirational, much as it was in 1969 when astronauts first walked on the moon.
Mhm.
Using the information that you have provided us,
Mhm.
cut.
Okay, you should copy this one to your notebook and fill the gap. Once complete the table, check your answer again to suggest the answer provided. Like cost here means like what will be the problem, what will be the benefits, you know, cost
Yeah.
and benefits, a good and a bad, and something like that. So basically, spend some time, like 10 minutes or something, like write it down, maybe. I'll wait for you then. Okay,
Resource
okay. So basically, what you say about a cost?
cost a lot of money,
Of course, it's very expensive. Space
material.
program are very expensive.
Yeah. And then there's material to make the
Equipment.
equipment, and it could cost like human life to go to like Mars because we don't know what's on there yet.
Exactly. We don't know, we don't exactly know what the risk could be.
Yeah.
So benefits is what do you think about the benefits then?
Benefit, we could explore more of Mars, know what it's like, and you can get more resources from Mars and bring it back to Earth. Three, I think the third one is you could um, I think And third should be, I guess you can be like the first people to walk on Mars.
Well, that would hit the headlines, and basically, it's just a step forward for humanity to explore the unknown. We might be able to gather the resources on Mars, and we might be able to build colonies there.
Yeah.
It's just the resources, I'm sure. Um, because we will eventually run out of resources on Earth, so we need a new place anyway.
Yeah, so
Yes?
very high financial costs, many tens of $1 billion.
Yes, we need $10. Very expensive.
No way of launching spacecraft large enough to carry humans to Mars. Economic spin-off from the technology. Humans are more adaptable than robot, and so we learn more. Pride and inspiration accomplishing goal. Yeah,
Hi, what?
pride and inspiration in
And accomplish the
accomplishing the
goal.
goal.
It would basically be benefiting our pride and inspiration, inspire people to accomplish the goals. It's a step forward for human.
Based on the cost benefit analysis, do you think it's a good idea to send human to Mars? Why or why not?
But why not? Of course, we should send them to Mars. What do you think?
Well, if the technology right now gets better, we could like improve, and there wouldn't be any cost of risking going to Mars. So,
So,
so I think it depends on like the technology. So I think it right now it's like no, because right
right
now,
now it's just like COVID time. Nobody has enough money. We need the economy to be able to fund space programs. Right now, everything's like we are barely making even. We are barely moving on with space technology right now. I think
yeah.
because of money, because of COVID, it destroyed the economy. It's tough now.
answer may vary. Some include what we could learn about the planet would be worth the risk. Risks of space travel for human. There are many risks for space travel. Some of the risks exist before the shuttle leaves Earth, while other occurs while the shuttle is in space. Other risks can occur when the spaceship returns to Earth after its mission. Space travel is dangerous, intense training is required in every aspect of the mission. It's rehearsed and carried out under constant observation, despite the safeguard. Some astronauts have been killed in accident. The Shuttle program had two disasters in January 1986. The Space Shuttle Challenger exploded just after liftoff, killing all seven astronauts on board. Among them was Christian, a high school teacher who had been the first teacher to fly into space. Radiation. When you leave the atmosphere to journey into space, you no longer have protection against solar radiation.
Mhm.
The atmosphere around Earth protects you from much of the dangerous radiation out in space.
But now, when
Most
we got there, no longer any protection. Most of the radiation comes from the sun, including UV radiation, which is very bad for your skin, linked to skin cancer.
Yeah,
Fatal level of radiation you're exposed to that. So deadly level of radiations. You don't want to get like UV shine on your skin all day and night like that. You can damage DNA molecules in human cells, causing a lot of weird things.
radiation is dangerous because it can damage DNA molecules in human cells. This exposure may lead to cancer or to birth defect in the next generation. Eye damage and vision loss are also possible effects of radiation. It can take years before many of the damaging effects of radiation become apparent. There are a number of ways to protect against radiation in space. The most important one is to ensure that the spacecraft is properly shielded against radiation. When astronauts go to spacewalk, their spacesuit must protect them from radiation and they need special lens in their helmet to protect their eyes. Diet and supplement can also help reduce the damage from radiation. For example, some research has shown that high dose of vitamin A accelerate and prevent from uh, some of the tumor associated with radiation exposure. Astronauts increase their consumption of vitamin A before, during, and after mission.
Health problems in low gravity, of course. In low gravity, basically human bones are not used to living in low gravity, or zero gravity. So our bones would eventually become way weaker and weaker if we go up to the upper atmosphere.
Yeah.
So they will have to practice every day like that. And it affects the condition inside the body too, not just the bones. It affects muscle, bones, spinal cord, blood flow, etc. And slowly these effects can cause significant health problems. Like muscle atrophy means you're losing muscles. Bone density loss means your bone is becoming softer and weaker. So when you get back to Earth, you may have problems with walking or something like that. Muscle atrophy is not something fun to talk about, really. When you're losing muscles, oh my god, it's terrible. You cannot even walk properly when you come back to Earth, if you lose muscle that way.
When astronauts are in weightless environment space, they are not being pulled down by gravitational force as they would be on Earth. Everything floats freely, including their hair. Weightlessness affects condition inside the body too. In particular, it attacks muscle, bone, and spinal cord. Any blood flow over time, these effects can cause significant health problems such as muscle atrophy and bone density loss. In the early day of space exploration, astronauts often come to, back to Earth unable to walk properly and had
There you go.
difficulty lifting
That's what I
objects.
was talking about.
Wow.
They have difficulty lifting object because of their muscles lost. Lost so much muscle
Yeah.
mass while in space. But once they experience gravity, their muscle quickly recovered. So, but you have to keep running like that, and
Yeah.
to train your muscles. Bones become quicker and stronger with use. The heavier the load they have to bear, the thicker they get. Uh-huh. In low gravity, bones are not bearing any weight, so they get very thin and lose density. There you go. So when you get back to Earth, you can break your bone easily if you're not careful.
Oh my god.
Mm-hmm. They're in danger of cracking if you get too thin. So these are the danger. Your spinal cord, your spine also. Change shape in low gravity. Well, space not a piece of joke. It's a lot. There's a
Yeah.
lot of danger on there too. You have to exercise regularly in space, and using equipment that provides resistance for muscle and bones. You train it like treadmill, for example. All
Yeah.
right, let's move on then.
Simulating what
What
happened to your
happened to your
body.
body in space?
An effect of microgravity can be simulated through an activity that you can perform yourself. Note, this is an optional activity. Read through all the steps before you begin. Write down the prediction of what will happen to the appearance of your face and circumference of your calf after lying down with your feet elevate for 10 minutes. You should perform this activity if you are healthy and have no problem with blood pressure or blood flow in your leg. If you are unable to perform these activities, you may choose to research the effect of microgravity on your own.
Activity. Can you just read it now?
Yeah. What you need: handheld mirror or camera, measuring tape or piece of string about 3
Or 30
centimeter
centimeter
long.
long pen.
And what to do? Look at your
Look at your
face in
face.
the handheld mirror
Hmm.
and remember what it looks like, especially the area under the eyes. You can also take a picture of your face with all your cell phone or digital camera instead.
Keep the phone or
Keep it
camera with you. Mhm. Mark your calf with a pen at a point just above the ankle. Just above the ankle, right? So here,
yeah.
right? Isn't it? Wait, this is elbow. Ankle is like down here. Mark your calf with a pen at a point just above the ankle. Measure the circumference of your calf. And the point you marked, you have to take measure. Use a piece of string. Using a ruler, measure the length of string you need to go around your calf. Record your measurement in a table like this. Wait. So you just record like how big the difference is, huh?
March half circumference centimeter.
face appearance after 10 minutes. Calf circumference. Then line the floor, couch your bed, use a stool, a chair, or pillow to elevate your feet. Stand position your feet higher than your head for 10 minutes. After 10 minutes while you're still lying down, measure the circumference of your calf in exactly the same place as the mark you made. Before you stand up, look at your face in the handheld mirror or take another picture of your face. Use a wall-mounted mirror. Go to it as quickly as possible. Look at your face. Basically, when you change position, your blood flow directly to your face, right?
Yeah.
When you lie down, like your blood flow to your face, but then your calf, basically your feet, receive less blood. So of course it will shrink down a little bit, but your face become a bit bigger, isn't it? So I hope you understand the visualization like that, because when you just lie down like that, of course the blood flow to your face, so your face will get a bit bigger a bit, but your feet will become a bit smaller, right? Because less blood is there now. Makes sense. Okay, think about it and maybe you can go down. Okay, so you should have predicted your face would look a little bit like puffier, like it get a bit bigger, yeah, puffier. And your cap circumference will be smaller, of course. Your observations will be similar to your predictions. If not, you might want to try the activity again. This time, try lying down for 15 minutes. Okay, this explains why after you wake up, your face look like,
Pale.
yeah. But after you work at your desk for a while, your face become a bit less like puffier. So our face actually do change. We don't look the same.
What caused these change? The change are caused by fluid, mostly blood.
Pulling in your face, gravity has caused the fluid in your leg to flow down to your head. This makes your leg a bit thinner and your face a bit fuller. Right.
Explain how it's related to microgravity. In microgravity, fluid in your body are not being pulled down as much as by gravity as when you are on Earth. The result is that more fluid stay in your head and upper body, and less is in the lower part of your body. The condition is called puffy face bird leg syndrome.
Uh, leg syndrome. That sounds terrible. Maybe not that terrible. It just doesn't sound great.
ISS. Now that you've finished this learning activity, look at the list of risks and benefit
And
of
benefit of
space.
space exploration you have created before starting the activity.
Exploration that you create before starting the activity. Add any additional risk and benefit to that you learn after considering the list. Would you take the risk and go live on the International Space Station for 6 months? Not really.
What do you say not really? Oh, look at all these bubbles for my milk tea. They have this strange green color. I like it, but it's strange. Would you take the risk and go live at the International Space Station for 6 months? That's a good question, right?
Yeah.
But then
No.
you come there not because of having fun, but because you have to go there to work.
Yeah.
Mm-hmm.
So no.
Yeah.
And that's the end of the learning activity 3.4.
That's the end
Oh.
already. Okay. Okay, I think we can just end there. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh cái đăng ký kênh á, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.